Hi, everybody. Good morning and happy Friday. So let's see. Oh, by the way, happy Lunar New Year. So yeah. Okay. So lunar calendar follow the moon.
Mhm.
If the moon is like you don't see anything, that's the first day of the month.
Mm.
And if you see the full moon, that's the 15th of the month. So we follow the lunar. Okay. So yes. And this weekend is the lunar calendar New Year. Uh, in the tradition, I think the East Asian like China, Vietnam, Korea, Japan celebrates the Lunar New Year.
Mm-hmm. Isn't it Year of the Dragon?
Yes, Year of the Dragon. Yeah. Okay, so today, today we will finish 7.6, and then we will have a review. I do have a question for you because last time we talked about to postpone the exam to Monday, but then I realized that day is a select event. We have prospective students visit our campus, and I need to show them about our math sequence at 11. So I cannot stay after class for your exam. So what are we gonna do? Do we want to move to Wednesday? Yeah, yeah. Yes, move to the Wednesday. Okay. All right. So yes, I will remind you about that.
So 21st.
Yes, 21st. Yes. Okay. All right. So let's see. Okay.
When do you want the practice exam due then?
The night before it. Okay. But of course, I hope you to do it earlier so you can ask me questions. Okay, so let's continue on 7.6. Okay, last time we talked about the trapezoid rule and the Simpsons rule, right? And let's see. It's good to look at the concept map. So the concept maps list all the concept of chapter 7.
Okay, I gotta print that.
Oh, didn't I give you one copy?
Oh wait, maybe you did.
Yeah. Okay. So, yes. So 7.6 right here. So two rule: trapezoid rule and the Simpsons rule. How do we remember? Okay, you have the interval from A to B, and we cut it into n subintervals. The A is also x0, and the B is x of n. The H is the step size, is the difference between 2 points, right? And here, so you can use x1 minus a, or you can use b minus a and then divide it by n. Okay? So after you figure out that, we have two rules, trapezoid rule and Simpson's rule. The formula is very similar. The trapezoid rule is h over 2. The Simpsons rule is h over 3. And how do I remember? I think about trapezoid rule, you're using a trapezoid. So you're using 2 points to estimate it. Right, everybody? Because there's a secant line passing through 2 points. Therefore, you divide it by 2. And the Simpsons method, remember each block is like 3 points. You use a parabola to approximate it. That's why you need 3 points to fix a parabola. Therefore, you have h over 3. Okay, so trapezoid method, 2 points, h over 2. Simpsons method, 3 points, h over 3. Okay, and then the left endpoint, the right endpoint, 1 copy. For trapezoid method, all the interior points, 2 copies. And Simpsons method, it follows the pattern 4, 2, 4, 2, 4. So alternates. Then you start with 4 and you end with 4. And it always like that because the end must be even. Okay? Each block of the Simpsons, okay, you need 3 points. That's why for the Simpsons method, the end must be even numbers. Is that okay, everybody? Yes. So last time we did example 1 and example 2, but we didn't find the absolute error. So let's continue to find the absolute error. Okay, so this is the same problem as example 1, but example 1 we use trapezoid method, example 2 we use Simpson's method. Now, yeah, we can find the absolute error. So the absolute error is the difference between the true value and the approximation. The true value is right here, 0.69314781. Okay. So, okay. 0.69, then what? Thank you. Minus this approximation, 693253968. And that equals, do you still have it? So your calculator, do you still have it on your calculator? Oh, I do have 2 copies of chapter 7 concept map. Who didn't get one? Okay. All right. So if you don't have that, okay, let me find it. I got, wait, let me see. Oh, I realized the number I got here is not this number. Let's see what happened. Sorry. No, I'm looking at the wrong page. E? Oh, yeah, yes. Okay, so the answer here is 0.000106787. Okay, so that's the difference. Let's see, does this make sense? Yeah, this digit the same 9, the same 3, the same 1 and 2. Yes. So yeah, it makes sense. So the difference is the one here and then this one. Okay. So compare this absolute error and the trapezoid method. Look at this. Where is our previous one? See, this is 0.0038. This is, don't block it. Hey, okay. This is 0.0001. Do you see this error is smaller than that one? So the Simpson's method approximation is better than the trapezoid method. Kind of makes sense because trapezoid, you only use the secant line to approximate it. The Simpson's method, you're using a parabola. So the higher degree the parabola, the approximation will be better. Okay, any questions? Where is it? Okay, right here. Thank you. Okay, so that is example 2. Any questions about example 2? All good? Okay, example 3. So example 2, we have the formula of the function, right? We can plug in the point in the function. But what if, like example 3, we don't get a formula of the function. We only get a table of points. So in this case, so here we're gonna use Simpson's rule, okay? And you can see here, so if you want to draw the picture, we have 0 right there, and then we have 6 here, and we want to approximate it using, here we have 6 sub-intervals, so 1, 2, 3, 4, 5, 6. And now here, what's the step size? What's H? The step size? Yeah, 1. The difference is 1. Right, everybody? Mm-hmm. And now, because we use Simpson's method, that this is the velocity. That is the time. Distance, because the velocity is all positive. In this case, distance is the same as displacement. Yes, everybody? So the distance here, because the velocity is positive, is the same as displacement. It's going to be integral from 0 to 6 v of t dt. Okay? That is the integral of the velocity from 0 to 6. And by Simpson's method, let's first write down the formula. We have h over 3, yes. And then the left endpoint is 0, 1 copy, right? How about the interior points? How many copies? 4. So 4, 2, 4, 2, 4. Yes. So 4 copy f of 1 plus 2 copy f of 2 plus how many copy? 4 copy f of 3 and 2 copy f of 4 and 4 copy f of 5, and the last one is 1 copy f of 6. Okay, so this step we just write down the formula of the Simpsons method. H over 3, left hand point, right hand point, 1 copy. All the interior points, 4, 2, 4, 2, 4. Okay. So now we can plug in. So what's H? 1. So 1 over 3. What's f of 1? Of f of 0? It should be v of 0. Okay. Yeah. V of 0 is. Yes. And then 4 times 1.3. 2 times 2.4. 4 times 4.5. And 2 times 6.7, right? Plus 4 times 3.8 plus 5.2. Is that okay, everybody? We plug in the numbers from the table. So left endpoint, right endpoint, 1 copy, all the interior point, 4, 2, 4, 2, 4. Yes, plug this in your calculator. What do you get? This is Simpson's method. Yeah, everybody put this in your calculator. Oh. What do you get? $61.8. Did you divide it by 3? Oh, no. 20.6. Okay. 20.6. Okay, so that is Simpson's rule. Okay, do you still have like more space? How about if the problem asks you to find the trapezoid rule? Okay, if you use trapezoid rule, what happened? H over what? 2, and then f of 0. How about all the interior points? 2 copies. So 2 times f of 1, 2 times f of 2, 2 times f of 3, 2 times f of 4, 2 times f of 5. And how about f of 6? 1 copy. Yeah, everybody? So yes, that's the difference between Simpson's rule and trapezoid rule. H over 3, H over 2, all the interior points, 4, 2, 4, 2, 4. And here, all the interior points, 2 copies. Okay, what's H? 1. So 1/2 f of 0, 0, right? So go in your calculator, you don't need to re-enter everything. You can go back to the previous line, change the 4 to 2. Change the 4 to 2. Change the 4 to 2. So your calculator, go back to the previous line. Only change those 4 numbers. This will save you some time. Yeah. What is your answer? Thank you. You see, they are close. So they're close. If you get like 20.6 here and you get 100 something here, then something wrong. Okay, yes. They're still close.
Will you have problems where you want both?
It should be set in the problem. Yes. So maybe you have problem ask you to find the both or yes. It depends on the problem. But be ready to know both. Okay? Yes. Okay, example 4. We want to look at this integral and use the Simpson's rule. Okay. In this case, we also have the function, right? Our function is complicated. By the way, can we integrate this guy? Nope. Nope. Not with the method we know so far. So, given any function, we can always find given any random function, it's so hard to find the integral. So for most of the function, we're not able to find the integral and get a nice formula. That's why numerical integration is very important. You can approximate. Just let the n getting bigger, then your approximation will be closer to the true value. Okay. Let's see here. Okay, so we want to use Simpson's method. So I always suggest you to draw the picture of the interval. For sub-interval, what's the midpoint? 2 and 4. What's in the middle? 3. And then because 4 intervals, so we need to cut it again. What's the midpoint between 2 and 3? And between 3 and 4? Yes. So now we have 4 sub-intervals. What is the step size? What's the difference? 1/2, like 0.5. Yes, everybody? Okay. Simpson's rule. So I approximately equals to h over what? Simpson's rule. 3. Yes, h over 3. And the left endpoint. Who's the left endpoint? 2. And then how many copies? 4. F of 2.5. And then how many copy? 2. F of 3. And then how many copies? 4. F of 3.5. Plus how many copies? 1. F of 4. Is that okay, everybody? Okay. So we plug in. H is 0.5 over 3. F of 2. Oh, this is our function f. F of 2, e to the, what's 2 times 2? 4. Minus 2 times 2, 4. Over ln, what's 2 plus 3? 2 plus 3? 5. Yes. We try to simplify it so we don't have too many things to plug in your calculator. Okay, we're plugging 2.5. What is 2 times 2.5? 5. Yeah, e to the 5 minus 5. ln, what is 2.5 plus 3? Yeah, 5.5. Okay, that's 4 copies. And 2 times e to the 2 times 3 is 6 minus 6 ln 6 plus 4 copies e to the 2 times 3.5. 7 minus 7 ln of 7? 6.5.
Oh,
Yes.
okay.
Yeah, yeah. And then 1 copy e to the 8 minus 8 over ln 7. Yes. Okay. Right. Now plug this in your calculator. Make sure in your calculator you need to put parentheses if you multiply by 4, right? In your calculator, you probably also need to put parentheses here as well, because you have this whole thing divided by ln 5. Okay. And let's see, what do you get? Oh, number, yeah. Yeah, when I look at this, I really want to copy this. And just change the number each step. You get the number?
I don't know if it's right, but
What do you get?
778.
7, 7. Oh, give me as many digits as your calculator display.
Okay, 778 point.
778 points. Oh, this is different than what I got.
Okay, yeah, then I must have made a mistake.
Anyone else? Sarah, what do you get? Oh, did you also multiply by 0.5 divided by 3? Ah, okay. I got a different nature. Okay, let's see. How about 3,000? This is about 700.
Oh,
I also get 700, but I get 777 point. Parentheses. Maybe the parentheses. I got 777.9799946.
Yeah, that's close to what I got.
Yes. So you figure out like.
Yeah, so I did
Mm.
LN4 instead of LN5.
Oh,
But yes, I
okay,
got the
okay.
same number.
Oh, you know you get the same number. Okay. Yes. So everybody practice using your calculator. Yeah.
No, that's fine. It's just I said it right as I finished it out.
Oh, you're clear.
I'm bringing
Okay.
out the computer calculator for that one, so I can type it in.
Yeah. Okay. So then that is the numerical integration. Any questions about that? That's everything we learned in chapter 7. And that will be on your exam 1. Okay, let's review chapter 7 again.
But we're only going to have one of these on the test.
Yes.
Right? I don't have more than one.
At most 2. If you, okay, so let's review that, and then we look at the practice exam together. You will see what type of problem's going to be on it. Okay.
Be able to use this for the
No, this one? No. Yeah. I put it here so that you can review those and learn and understand those and remember all these methods. Okay? So I hope you can hide this sheet and rewrite everything on your own. If you can do that, then that means you can remember and understand all the concepts in this chapter. Yes. Okay. So 7.1. Remember 3 types of integrals? X to the n, exponential function, and 1 over x. We get natural law, absolute value of x. And e to the ax. Remember, just divided by the coefficient of x. Do we divide it by x here? No, that's the common mistake. So be careful with that. And then 7.2. Use substitution. So we have 4 steps. Let u be the inner function. By the way, we don't have product rule or quotient rule for integral, right? If you see a product, it probably you need to either distribute or use the u substitution. Okay, so 4 steps. Let u be the inner function, and then find the du in terms of dx, and then plug everything back to the integral. You get integral with u only. You don't want to see a mixture with u and x in it. Okay? And then you can integrate, then plug the x back. For definite integral, you either change the x values to u values and then plug in the u. Or you keep the x values, and then you integrate the u integral, and you plug the x back and put in the x values. Okay, everybody? And then we talk about the indefinite integral. It's the family of antiderivatives. And then the definite integrals with the bounds, the limit of integration. This is going to be the net area of the function. Net area, if the area is above the x-axis, it's going to be positive. If the area is below the x-axis, it's going to be negative, right? And the total area is the integral of the absolute value of f. This will put the area below the x-axis to be on top. So all the area now are positive. So they won't cancel out with each other. We learned 2 methods to compute the definite integral. Method 1, using the fundamental theorem of calculus, and we find the antiderivative. We plug in the upper limit minus we plug in the lower limit. Yes, everybody? Second method. This is when the function f of x is a line or a circle. Line means it's a linear function. Circle has the form square root of like 25 minus x squared, like this form. Is that okay, everybody? You see square root and constant minus x squared. This is a circle. Then you can draw it, and then using the area of this geometry figures to figure out that. Is that okay, everybody? 2 methods. In the 7.5, we talk about area between curves, right? And so the area is integral from a to b. You use the upper function minus the lower function. And how do you find intersection points? Yeah, plug in the points, and hopefully they are integer points. Okay, so it's easy for you to plug and find them. And then we talk about the application consumer surplus and producer surplus, right? In this case, you need to solve the system of equations to find the intersection points, the equilibrium points, right? And then you get the quantity and the price. Consumer surplus is the demand minus the price, equilibrium price, right? We integrate that. And producer surplus is the price, is the upper function minus the supply. Yes, everybody? And then we talk about numerical integration, the trapezoid method and the Simpsons method. Yes. So not a lot, right? Okay. So practice those, and the practice exam is right here. So this is the practice exam 1. So let's look at this. By the way, your actual exam has less problems than the practice exam. And I try to make the practice exam like harder. Okay, so yeah, when you see the actual exam, hopefully it's a little bit easier than this. Okay. Number 1, evaluate the integral. So what do? If you see a product, you're gonna distribute, right? Like your quiz. Did we go over the quiz last time? Yeah, yes, okay. Yeah, we distribute and then integrate term by term. Okay, and then here, using U substitution. What is your U? Yeah, everybody look at the problem. What is your U?
5.
Yeah, 5 square root of x plus 3. And then when you take the derivative, you get the 1 over square root of x. So this will contribute to your du. Okay, good. What is your u? Yeah. And then this is just gonna relate it to your du. Okay?
So if you do the outside of that function, will you end up with the same?
What do
I
you
know
mean?
You said like it's for the denominator, right? If we do u substitution, you basically end up with x.
Yes.
If you do the outside of b,
Outside?
yeah, so the outside of the function, not the
Like
inner
the cube parts?
No, I'm talking about x to the 5th power.
Oh no, it
plus
won't
3.
work because then you're not able to change this.
Okay.
Yeah. It has to be the inner function. Yeah, for that to work. Okay, and then definite integral. Okay, what is your u?
ln x.
It's the whole thing is 7 ln x plus 5. Yes. And then this is a application problem. So you want to, so you're giving d prime. You want to find the d, so you integrate it. What's your u?
It has to be the square root of t squared.
Just inside the square root, not including the square root. Yeah, yes. Right, everybody? Okay, how about here? Area between two curves. So here it gives you the left x and the right x. So your x goes from 0 to 1. And then you kind of draw the picture to figure out which one is upper function, which one is the lower function. Okay, then we can integrate that. And round your answer to 4 decimal places. Okay, this problem, you need to find the intersection points, right? It does not tell you where the x start and end. So you need to find the intersection points. And you can do that by what? Either put the integer point to figure out which point they meet, or you solve the system of equations. Okay, how about here? You have demand and supply. You solve the system of equations and you find the equilibrium quantity and price, right? And then you find the consumer surplus and producer surplus. Okay, look at the table. Simpson's method, trapezoid method. You're gonna do both, okay? What is the step size? What is the step size? 3. Yes, the difference is 3. Yes. Okay. And then this one, Simpson's rule. So you also draw the interval, figure out the edge, and then, yes, set up the equation and find it. Okay, so that is the practice exam. So I give you the solution. Remember, you first use pencil to finish the practice exam, and after you finish, look at the solution and check your work. So this problem has 8 points, this step is 3 points, this step is 8 points, and then one mistake, subtract 1 point. So you also need to grade your work. Okay, estimate your score for each problem. Like this problem is 8 points, so this step 1 point, 2 point, 3, 4, 5, 7, and 8. So see how many steps you arrive, subtract how many mistakes you make. So you can estimate your scores. So write down the score for each problem and add them up to see the total score. So after the actual exam, I give you back, and you will need to do exam correction for the actual exam. You also need to fill out exam wrapper. It's a self-reflection survey. So it's asking you, okay, compare your scores of the practice exam and the actual exam. Are you improving? And what mistake did you make on the actual exam that taught you something? And what will you do differently next time to improve? And how can I help you? Okay, so that's the practice exam. Any questions? No? Okay, so let's see. Do you have 8.1 worksheets? No? No? Yes? No? Okay. So we still have 10 minutes. Okay, what do you think? Have you printed out the practice exam? No?
Not yet.
Not yet? Okay. So let's see, what do we want to do? Okay. Maybe I can print out the 8.1 for you, and then we can start. How many of you need 8.1? Raise your hand. One? Oh, just one? Okay. So let's see. 8.1. Integration by parts. Okay, just one? All right. So let me grab it real quick.
How was the test?
Yesterday?
Yeah.
Yeah, I was gonna ask you too.
So I didn't take it. I'm taking it today.
You take it today?
Yeah.
I
You
don't
talking
know.
about the material science? Yeah. Yeah. I'm not doing it on that shit. Charlotte texted me and she was like, yeah, I think that one was.
Yeah.
I feel like it was just the third page and it was just like difficult. I said I didn't remember anything.
I honestly struggled more with like chapter 1 and 2 stuff than chapter 3.
Really?
Yeah, but I think it's just because it was more fun.
I guess that makes sense. You just have to like, the first page is just literally saying what type of material it is.
That one's,
Yeah, that was.
yeah, you post that one.
Yeah.
You're like, oh, good, I got 3 points. The rest of the test is bad.
Yeah.
That's 8.1.
At least you
And-
get something right.
Yeah.
I also make the chapter 8 concept map. So
Oh, awesome.
yes, that's the chapter 8 concept map. So you have an idea what we're gonna learn in this chapter. All right. Okay, so session 8.1. Integration by part. So chapter 8, we're gonna learn more integration techniques and more applications. Okay, so 8.1. Let's see. Okay. All right. So the integration techniques we have learned so far are the use substitution, right? So integration by parts is another integration techniques, and it's similar to the product rule for derivative. So how do we get a derivative? Okay, do you still remember for the product rule for derivative? We have, let's see,
was
what
not
happened?
working with you.
Yeah. Okay. So uv is derivative of u times v plus u times dv dx.
Yeah, you just split.
Right, we just flip them. Okay, now what we're gonna do is we want to integrate both sides with respect to x. So d uv dx integrate with respect to x. So and then here we're gonna put the v in front of that one. So du dx dx. And then here integral u dv dx dx. So both sides apply the integral. So integral, is going to be the sum, and we have the dx at the end. Yes, everybody? Okay. Do you see dx cancel? Here we have integral duv. And then here dx cancel. We have integral v du plus dx cancel. We have integral u dv. Yes, everybody? Okay.
Is it important to write out the entire function and what the dx is, or is that just like the
Oh, we're just
true
deriving the
form?
formula.
Yeah,
Yeah, after we derive the formula, we just use the formula.
I was gonna
Yeah.
say because we just do VD.
Yeah,
Okay.
VDU, yeah.
I'm just making sure that now we know the theory.
Yes. And now, okay, do you remember what's integral of 1 dx? It's,
dx is x.
yeah, it's x. And 1 dy is y. Exactly. So integral of 1 duv is uv. It's whatever
Oh,
the
okay.
variable is. So this part is just the variable uv. Okay. Nice. Now both sides subtract integral of v du. We get integral u dv equals uv minus integral v du. So this is the integration by parts formula. And we're gonna memorize it. Okay? And let's look at the formula. So this is u. Do you see here we want to differentiate u? Okay, so u is something we want to differentiate u. And do you see dv? And we start with dv and we want to get v. So we want to integrate dv. So u is something we can differentiate and make the problem easier. dv is something we can integrate and the problem is not that hard. Okay, so keep that in mind. Okay, everybody read with me. Integral u dv equals uv minus integral v du. Again, loud. Integral u dv equals uv minus integral v du. Again, integral u dv equals uv minus integral v du. Now close your eyes. Integral u dv equals uv minus integral v du. Yeah. Just remember the formula like remember your name. Okay, I have your phone number, right? Can I call you and meet that? What is the integration by part formula?
I'll just get it tattooed. It's fine.
What? This is how you get.
Yeah, I got my blank arm. I'll just get it tattooed.
Okay. If you really do that, okay, I will let you to do it. But it's real tattoo. I will test you whether you can wash it. If I can wash it, that's not a tattoo. Okay, that would be a cheating. Okay. All right. Okay, so let's continue. And let's see. Okay, so we keep in mind, u is something we can differentiate and make the problem easier. And dv is whatever left. We want to integrate that. Let's look at the first problem. ln x. Are we able to integrate ln x? No, that is what we're looking for. Are we able to differentiate ln x? Can we differentiate ln x?
Yeah.
Yes. Right. So, oh, that is u. Okay. And whatever left is going to be dv. So you draw a line like that and you put the u here. So u is ln x. dv is whatever left, dx. Yeah, write it down, write it down. You have your pencil? Write it down. So that's your u, that's your dv. Okay, now we're gonna differentiate the u. What is du? What's the derivative of ln x? 1 over x dx. Yes, everybody? We need to have the dx. Remember, two kids play on the seesaw. We need both sides, the differential. All right, how about the v? So we integrate both sides. Integral of 1 dv is v plus integral of 1 dx.
X.
Yes. And this is the place you don't need to put plus c. Okay? Just integral of 1 is x. Okay, nice. Now we plug in. Integral of u dv is uv. What's u? What is u? ln
Is,
x. v x minus integral what? v, which is x, du, 1 over x dx. Great. Oh, what happened with x and 1 over x? They cancel. We just get 1, right? What is integral of 1? X. Okay, so at the end, we do plus c. Is that okay, everybody? Yeah, this is integration by parts. So figure out the u. U is something you can differentiate and make the problem easier. And the dv is whatever left. Okay, and draw the, draw like this. Find the du, find the v, and then plug in the formula. Have a nice weekend. So you can work on your practice exams next week. If you have questions, you feel free to ask me the practice exams or any problems in class notes or your homework. Yeah.